solve one more problem to apply the concept of work done. So, let us take the problem example 4.3 from the book. So, this is yet another situation for applying the same formula. Let me read it, carefully listen. An object of mass 1 kg is sliding from a top to bottom in a frictionless inclined plane of inclination angle theta is equal to 30 degrees. And the length of the inclined plane is 10 meters as shown in the figure. So, let us draw the figure later. Now, what is asked? Calculate the work done by gravitational force and normal force on the object. Assume acceleration due to gravity g to be equal to 10 meters per second square. So, when such problems are given, we should understand what the problem talks about, what situation the problem is presenting before us. Then you try to identify the parameters, and then you see how we can relate these parameters and the given concept or the situation in the problem in the standard equation to find the answer. So, let me just identify the situation here. What is happening? An object of mass 1 kg is, so mass is given, it is sliding. So, sliding means it is coming along the inclined plane from top to bottom. So, every single word is important, from top to bottom. That means the initial position is the top and the final position is the bottom. That is how it slides in the frictionless inclined plane. So, this is very important because in unit 3 we have talked about friction, and if it slides in the frictional plane, then the force of friction should also be included. So, in this situation they have said frictional force need not be included because it is a frictionless surface. And the inclination angle is 30 degrees and the length of the inclined plane is 10 meters. So, the angle is 30 degree and the length is 10 meters. So, let me represent all these things in the diagram. So, diagrammatically let me redo. In your book, a diagram is already drawn and given. In case if the diagram is not given also, you should be able to identify or understand the problem and draw the diagram by yourself. So, let us try to draw the diagram by ourselves and then apply the parameters in the standard formula. So, we have to see this is the inclined plane. So, inclined plane of length 10 meters, that means this is the top and this is the bottom. So, it is moving from top to bottom. So, the initial position is top and the final position is the bottom, and that is how it is going to incline. And therefore, from here to here the distance is given to be 10 meters. From here there to here the distance is 10 meters. And then the inclination angle is 30. So, inclination angle is always the angle between the horizontal surface and the plane, the slanting plane. And therefore, this is given as theta. They have used the term theta. So, this inclination theta is equal to 30 degrees. So, I have marked in this and I have prepared the base. Now, mass of 1 kg is sliding. So, as it slides from here to here, at one point of time the mass would be somewhere in between. So, what is the mass? Mass is 1 kg. It is just going to slide down. So, that means this is the direction of displacement. So, this is the direction of displacement. Fine. So, now calculate the work done by the gravitational force. And they have talked about the normal force also. So, to this situation, the situation here is this slanting plane and a mass is coming from top to bottom. Now, what are the forces that can act on this particular mass? One, normal force. We always draw the normal force. What is normal force? Normal force is exerted by the surface on the object, and therefore, it is in this direction because it is a slanting plane. The surface is like this, so normal should be perpendicular. Another force can be the gravitational force. Gravitational force will always act downwards. Even though it comes slanting like this, the gravitational force will always be acting in the downward direction, and its magnitude is equal to mg. Okay. So, now if this is theta, then this angle is also equal to theta. So, normal force, gravitational, both I have drawn. But now what is asked, carefully see, work done by gravitational force, that is the first question. And then the work done by the normal force, which is the second question, both you are given. So, first let us take work done by the gravitational force. So, gravitational force is acting downwards, but how this motion is? Motion is in this direction. Therefore, not the complete mg is going to act on the object in displacing it, but only a component of the. So, how can we take the component? If this is theta and this parallel component is mg cos theta, and this component is mg sin theta. Now, carefully see, of the two components, which is in the direction of the motion, or which component it is possible for the object to be pushed. So, mg sin theta is the one in the direction of the motion of the object, and therefore, we need not worry about this component mg cos theta, which is not going to help or which is not going to act on the object in displacing it, and therefore, mg sin theta is the component of the gravitational force which should be considered for calculating the work done. So, shall we write the formula for work done now? So, work done is equal to f cos theta dr. This is the standard formula we write, or you want to write if it is going to be constant force, then r initial to r final. See, now in this case, what is theta? Theta is, in this definition, theta is supposed to be the angle between the direction of the force and the direction of displacement. Since theta is already used for angle of inclination by the plane, I want to replace or rewrite this theta using phi, because I do not want you to get confused between theta and phi, because the problem is already used the notation theta for angle of inclination. I am just writing the work done to be f cos phi, where I am defining my phi to be the angle between the direction of the force and the displacement. Directions of force and displacement. Now, look at this. So, now we are this is the direction of displacement, and mg sin theta is the component of the gravitational force. Both are in the same direction, and therefore, phi is equal to 0. So, cos phi is equal to 1. So, let us see whether we have all the parameter and substitute in the work done. Let us deal with the first case. So, work done is equal to F is gravitational force cos of phi integral dr. Let me just put it as R F minus R I. So, work done due to gravity is equal to, so this is nothing but mg sin theta. Mg sin theta is this value, because only that part of that component of gravitational force is acting on it to slide, And then what is cos theta? In this case, I can even write theta to be 30 degrees. It's already given. So, let me just put sin 30. This is f. Cos phi already is, we have calculated 1. And then what is rf minus ra? That is the total distance. Since it is travelling from the top to the bottom, the total displacement would be equal to the length of the inclined plane, which is already given as 10 meters. So, 10 meters. So, what is sin 30? It is half. So, and m is given, g is also given. So, let me just substitute. The mass of the object is 1 and g is given as 10, sin 30 is half, and already we know these values, which happens to be 50 joules. So, the work done due to the gravitational force, work done by the gravitational force happens to be 50 joules. Now, there is an additional question, one more is also asked. What is the work done by the normal force? So, in this case, normal force is acting in the upper direction or in the perpendicular direction to the direction of motion. So, if you carefully see this picture, the normal force is acting upward and one of the components of the gravitational force is acting exactly in the opposite direction. And the sliding is taking place in this direction. Therefore, the normal force is perpendicular to the displacement. We have already said. So, the normal force is this and the direction of displacement is this. So, the angle between them is going to be 90. Therefore, work done by the normal force on the sliding object is 0. So, the second answer. So, since the normal force is perpendicular to the direction of displacement, the work done by the normal force is equal to 0. So, in this problem, we have seen how the situation can be drawn diagrammatically, how all the parameters can be substituted or drawn diagrammatically. And then once you develop the diagram, the directions become very clear and then you apply what is asked to the standard formula and then identify the type of the force. In this case, the force was one case is the component of the gravitational force. In the second case, the force was the normal force. So, in such problems on work done, you should understand what is the force that is having the displacement and what is the direction between that force and the direction of displacement, that angle, and then what is the total displacement that has taken place. So, if you are able to identify these things from the given problem, application in the formula becomes easy. So, this is how you try to learn, understand the given concept in the problem and then apply it in the appropriate equation.